and its properties. Now, what is modulus of a complex number? First of all, let us consider a complex number z1 equals to a plus b iota. Now, modulus means the magnitude of this complex number. Sometimes it is called as absolute value of complex number. Now, modulus of z1 will be written as shown in the screen right now. The format of modulus of any complex number z is equal to under root real part square plus imaginary part square. Keep in mind. So the same thing goes here, under root a real part square of this complex number plus imaginary part square. So the modulus of z1 is equal to under root a square plus b square. Now let us change some sign of both the parts and let's see what are the results coming out after then. Let us consider z2 where the real part is negative but imaginary part remains positive. Let us consider z3 where the real part remains positive but imaginary part is negative. And let us consider the last one case where both the parts, real as well as imaginary, are negative. Now for this one, z2, if we find out the modulus of z2, it will be under root real part square, that is minus a whole square plus imaginary part square, and the final result will be under root a square plus b square. So as you can see, the value remains the same with the original one. There is no difference here. Now mod of z3, the absolute value of z3 will be under root real part square plus imaginary part square, that is equal to under root a square plus b square. Again we are getting the same value as you can see here with the other two parts. Now if we find out the value of mod z4, it is again equal to minus a whole square plus minus b whole square, and that is again equal to under root a square plus b square. So again we observe that the value remains the same, the value remains the same. There is no difference in all these four values. So what is the conclusion? The conclusion is it doesn't matter, the sign conventions doesn't matter at all. The absolute value remains the same of the same imaginary part and the real part. Now let us go through the properties of modulus of complex numbers. The first property of modulus is that mod of a complex number is equal to 0 if and only if the whole of the complex number is equal to 0. Now let us consider some situations under this section. Case number 1, let us consider a complex number z1 where the real part is a but the imaginary part is considered as 0. So now in this case, if we find out mod of z1, we get modulus of z1 equals to under root a square plus 0 square, and that is under root a square, and that is a, which is not equal to 0. So the modulus is not equal to 0 in this case. Now let us consider another condition where real part is 0 but imaginary part is something as b iota. Now let us find out the modulus of this complex number. In this case it will be 0 square plus b square, and it will give us under root b square, and the final value will be b, which is also not equal to 0. Now let us consider the final situation where both the parts, real as well as imaginary, are 0 in this case. Now if we find out the modulus of this complex number, it will be 0 square plus 0 square under root, and that is equal to 0, and that is equal to 0. So therefore what we conclude is the modulus of Z3 is 0 only and only if the real and imaginary both the parts is 0, that is whole of the complex number is 0, then only the modulus is 0. So this condition is justified. Now let us move on with the second property. There are 4 properties in total. Now this is the second property. In second property, modulus of negative complex number will be equal to modulus of positive complex number. Now let us consider a scenario z is equal to a plus b iota. The negative of this complex number will be minus a minus b iota. The whole sign changes for both the real and imaginary parts. Now if we find out the mod of z, we get under root a square plus b square, whereas if we find the modulus of negative of z, we get again the same thing, a square plus b square under root. So the values are equal. Now let us go through the third property. Now in case of third property, modulus of the product of z1 and z2 is equal to modulus of z1 into modulus of z2. Let us consider a scenario where z1 is equal to 1 plus 2 iota and z2 is considered as 2 plus 3 iota. Now there are two complex numbers. Now if they are been multiplied, let us consider the left hand side first. We have to find their product first and then we will find out the modulus of it. So the product is 1 plus 2 iota into 2 plus 3 iota, that will be equal to 1 into 2, 2 plus 3 iota plus 4 iota, that is 7 iota plus 6 iota square, that is equal to 2 plus 7 iota plus 6 into minus 1, because iota square is equal to minus 1. Iota square is equal to minus 1. Keep in mind. Now the final result is 2 minus 6, that is minus 4 plus 7 iota. So now the mod of z1 into z2 will be equal to under root minus 4 square plus 7 square, that is equal to under root 16 plus 49, that is equal to under root 65. So this is the value of left hand side of the expression. Now let us calculate for the right hand side and see whether the values are equal or not. In the right hand side we have to individually find out the modulus of both the complex numbers and then multiply them. So modulus of z1 is equal to under root 1 square plus 2 square, and that will be multiplied to modulus of z2, and that is equal to under root 2 square plus 3 square. This will be equal to under root 1 plus 4 into under root 4 plus 9, that is equal to under root 5 into under root 13, and that is equal to whole of under root 5 into 13, that is equal to under root 65, and both the cases the values are equal. So therefore, let us now continue with the fourth property, which is the last one. In this case, we will go through with the division part. Now z1 divided by z2, the whole modulus will be equal to mod of z1 divided by z2. Now let us consider the same example. Let z1 be equal to 1 plus 2 iota and z2 equals to 2 plus 3 iota. Now left hand side expression of this property will be equal to, first we will divide z1 and z2. So z1 is equal to 1 plus 2 iota divided by z2 is equal to 2 plus 3 iota. To divide this, we will first rationalize. We will always go through rationalization process. So it will be 2 minus 3 iota in the denominator, and in the numerator as well. You'll multiply it. So the numerator part will be equal to 1 into 2, 2 minus 3 iota plus 4 iota plus iota minus 6 iota square, the whole thing divided by under root, sorry, not under root, 2 square minus 3 iota square, that is equal to 2 plus 6 becomes 8 plus iota, and denominator part 4 minus 9 iota square, and that is equal to 8 plus iota divided by 4 plus 9, that is 13, and in the standard form it will be written as 8 by 13 plus 1 by 13 iota. Now this is the final value. We will find out modulus of this value. So it will be equal to under root real part square plus imaginary part square, and that is equal to under root 64 by 169 plus 1 by 169, and that is equal to under root 65 by 169. If we reduce it, it will be 5 by 13 under root. Now let us consider the right hand side of the property. Now right hand side, mod of z1 divided by mod of z2, that will be equal to under root, mod of z1 is 1 square plus 2 square, and then mod of z2 will be under root 2 square plus 3 square, that is equal to under root 5 by under root 13, and the whole thing can be written as under root 5 by 13, which is exactly the same as the left hand side. The values are equal. So this property is also satisfied. So this is how all the properties of modulus is to be practiced by one and all to clear your concept. In the next lecture we will be going through conjugate of complex numbers and its properties. See you in the next lecture. Till then, bye bye.